Okay, so we're going to continue our work yesterday that we were studying if statements. And I think the best way to understand if statements is just to learn by doing. So I've collected a lot of examples this week. And in fact, a lot of the examples I collected, I pulled straight from final exams from previous years. So I don't know if you know this, but the university library here collects final exams for all your courses. And it is a great resource to go and check them out. And they're also a great resource for practicing. So the questions I'm giving you today are straight from final exams. Well, when I indicate them. So there's this term in computer science called factoring. You may be familiar with this in mathematics. To factor something is to take some type of expression and to break it into smaller pieces as a product. In a similar way in computer science, factoring means the same thing, right? To take some problem, a big problem, and to divide that problem into smaller pieces, where you then write the smaller pieces and then connect them all. This is, in fact, the essence of computer programming, right? This is this notion of abstraction, that is, to take something complicated and hide the details behind some definition, is one of the most critical aspects of computer science, right? So this is what I'm going to hope to teach you guys over the semester, right? How to take a problem and to break it into smaller pieces. Anyways, that is called factoring. So to refactor something, it means to sort of like disassemble the thing that you're working on. Right? So more precisely, code refactoring is the process of restructuring existing computer code, right? Changing the factoring without changing the external behavior. So in English, this just means to take your code and make it simple, more simple without changing the behavior of the code. Right? Because code can be equivalent to other code, and some code may be ugly and big, and other code may be elegant and short, and we want to strive to move our long, complicated code to short, elegant code. So here is the if statement. If x is greater than 1, then if y is greater than 2, if z is greater than 3, then print hello. Okay, this is a perfectly syntactically correct if statement. How can we simplify it? Yeah, this is equivalent to just saying if x is greater than 1 and y is greater than 2 and z is greater than 3. Right? These are equivalent statements, right? So when you have consecutive if statements, you can tie them together with a conjunction, with an and. Right? This means this condition has to be true and this condition has to be true and this condition has to be true in order for this to print. Right? So we can compactify that into one line. So this is not the case when you have if and else's, right? Then things get a little bit more hairy. But this is certainly something that can be simplified. So that's a sort of tiny example of this is technically a code refactor, right? I would prefer this one to this one because this if statement makes it very clear what is the condition that has to toggle in order for oh, maybe I should have put a print there. I don't know why I put an X. First mistake. Here's another piece of code that I would like to refactor. So let me define a function called foo, which takes in a value x. If x is greater than 0, return true, else return false. How can I simplify this? Make the if statement inline. Okay, but how can I simplify it even further than that? Let's walk through this, and maybe I'll give you that is technically a correct answer, but I can make a further simplification than that. Oh. What is going on? That's better. Okay. Yeah, just return x greater than 0, right? Think about this statement it's saying. It's saying, if this statement is true, return true, else if this statement is false, return false. Right? This is a very typical thing that new programmers do. Right? But do you see that this statement is precisely equivalent to this? Right? You're basically saying, if true, return true, else if false, return false. Right? The surrounding if statement is totally redundant, right, in that sense. Right? So that's another common one that programmers make. I'll simplify this one. If x is greater than 0, then y is true, else y is false. So it's a little variation on the slide from before. So if x is greater than 0, what does x greater than 0 evaluate to? True. So what is y being set to? Don't even need an if statement, right? So when you're working with Boolean values, I know sort of logically this makes sense in your mind, right? Oh, if x is greater than 0, then y should get true. Else if x is less than or equal to 0, then it should get false, right? As a logical statement, that reads nicely, but in fact it is redundant. It's wasted code, right? Because all we're concerned about is the actual sort of value that x greater than 0 evaluates to. Any questions so far? Because I need you guys to stop me and ask questions if things get confusing, because it just gets sort of more complicated as I go. This one? So this is an assignment, right? So that's going to get associated, that's going to get looked at last, right? So Python is going to look at everything to the right of the assignment and then try to evaluate it. And if it succeeds in evaluating the value, it's going to assign that to y. So the Python walks to here, it reads this line, it determines that there are no syntactical errors, it finds this equal, it then evaluates x greater than 0 by first looking for x, right? If it exists, then it evaluates that predicate. This gets true or false, and then finally it gets assigned to y. Okay. Here's another one. If x is greater than y is true, then set z to 1. We'll do this in 2 simplifications. What's the first simplification I can make? Yeah.
Did you just say, like the previous slide, what causes this int?
Yes. That's the last simplification I want to do. Let's do a simpler one first. Yeah.
We could write z equals 1 if x is greater than y.
Okay, we could do it in line. What I'm trying to say is, how can we simplify that condition specifically?
Just say x greater than 1.
Yeah, we're always checking if the condition is true. It's redundant to say if this condition is true, right? Then continue, right? This is not required, right? And a lot of people do this as well, right? They say, oh, if the condition is true, then do this. It's like, well, checking if the condition is true is the thing that is implicitly being done. You don't have to explicitly state that it's true. So the first simplification I want to do is this, right? If x is greater than y, then z gets 1. There's one more simplification. This I would already say is fine, right? Because this is sort of unique to Python or other languages. But the latter, the third thing, is there's a term called Pythonic. Have you ever heard it? So when we do stuff in Python, it's somehow different than we do it in C. So the style which we code in Python is called to be coding Pythonically, right? So this is like C code, and this is Pythonic. Right? I don't invent the terminology. I just regurgitate it towards you guys. Yeah. It's equivalent, right? Remember I showed you that I could say true plus 1? That already indicates that the Python is treating it both as a Boolean and as an integer. The fact that it prints true is for us. I think like Python just remembers true, false as 1 and 0, right? And for us humans, right, it has to print out true and false. Right, so this is definitely bad. This is okay. This is the most Pythonic. But if you're confused by this is totally fine. Though you should be able to read this, right? I was looking through your exams, and it's a lot of, here's some code. What does it output when I give it this? Are the following pieces of code equivalent? And I may give you more time to think about this stuff, because I need to waffle for 1. And 2, I do want to think about this. So block 1, if x is greater than 0, then print a. Else if x is less than or equal to 0, and x divided by 2 leaves no remainder, or x remainder 2 is 0, print b. The second block is exactly the same, except I remove this condition from the second if statement, or the else statement. Are they equivalent? And when I say equivalent, I mean under all inputs, will they output the same thing, right? Because obviously they're not equivalent because I removed this, right? But they're equivalent in a different way. Think about it for like 30 seconds, right? And if they're not equivalent, you should be able to give me an x right? Where block 1 will do something different to block 2. Good job. They are equivalent. And they are equivalent for this reason. When you have if-else statements, right? Each if statement in the if-else is going to trigger. And if it triggers and doesn't toggle, that is the condition fails, you can assume that the failed condition is true moving forward. Maybe I didn't explain that well. Okay, so specifically in this example, if this line fails, right, if we don't print A, then what can be assumed here, right? I can assume at this point that x has to be less than or equal to 0, because otherwise it would have printed A, right? If I make it to this line, I'm assuming that I can also append the not conditions from the thing before, right? How can I explain this better? Yeah.
Might be easier to think about if the condition is true for any if block, it instantly exits the structure of its.
Yeah, but it's the opposite case I'm concerned about it.
So if it skips the first if, it necessarily is not.
Yeah, that's what I'm trying to get at. But okay. Again, I'm just going to walk through this and hope my explanation that I wrote here can stand. Otherwise, go to the lab and try to think about it a bit. But if I execute this line, if x is greater than 0, then I print A and we're done. Right? If this line fails, that is, if x is less than or equal to 0, we skip this code block and move here. But as soon as I get to here, I know I can conclude that x has to be less than or equal to 0. Otherwise, A would have printed. So thus, this condition is redundant, right? Because by this point, this is just the negation of this condition, right? So anyways, maybe you have to stare at the example for a bit later, but they are indeed equivalent. So maybe I'll show you another example, and it may make it more clear. So are the following pieces of code equivalent here? So this is the same example with a change. I removed the else from this. Now there are two consecutive if statements. Right? What about now? And remember, if you're claiming that they're not equivalent, then give me an input where it's going to do different things for both blocks. Shh. Up there, yeah. So 1? Okay, sure. Let's say x is 1. Okay, so let's take this. If x is 1, then we walk through this, it prints A, and then this gets skipped. If x is 1 here, then it prints A, gets out, and skips. No, 1 wasn't good enough. Because it did print in both instances. You're close, though. Okay, let's pick 2. Right? If 2 is greater than 0, then print A, so that prints. Then this one checks that x is less than or equal to 0, which it's not, so B doesn't get printed. So block 1 prints A. If I move with 2 into block 2, I get if 2 is greater than 2, print A, which triggers. And then if remainder 2 is equal to 0, then it prints B, so it also prints B. Right? So there's a difference between having an if-else, right? That's one if statement, then putting 2 if statements one after another, sequentially, right? So in the if-else block, we were able to carry over assumptions to the next else if, but in if statements, it doesn't matter, right? This if statement here is independent of the ifs that surround it, right? So no assumptions are going to carry forward. So as the gentleman up there said, if we let x equals 2, you can see that the first if block prints A only, and the second if block prints A and B. Any questions? I know this is sort of getting dicey, but it requires some practice in the lab. It's half about me waiting for questions and half about me wanting a drink of coffee. So, okay, so question. A question from Final Exam 2014, question 1, part D. What is the value of z after executing the following? So I am going to give you like maybe a minute because this is something you should definitely be able to do because it was on one of the previous finals. And so if you can't do it, we got to sort you out a bit by like sending it to the TAs or my office hour. Oh, sorry. So one more thing. In order to save vertical space, I'm going to start defining variables like this. It's totally, you can do this in Python. These are objects called tuples, which I don't want to explain yet. So for the time being, just allow me to define variables like this, because otherwise I'm going to run out of vertical space in my slides. But you can do this in Python too. You can do this in Python also, because this you have in Python 2 and in Python 3. Anyone have any answer? Up there, yeah, in the shirt. 6? 6. Okay, so let's step through this together. So x is 1, y is 2, z is 3. So on your exam, I'd recommend just going into this code and overwriting the variables with the value. I can't do that because this is a computer, but let's use our imagination brushes to do this, right? So if x is 1, if 1 is less than 2, so do I go in? Yes, so that's true. So I enter this if statement. If 2 is greater than 4, false. I go to the else, and the else triggers. Z is 6. Okay, boom. That's already 1 mark on your final exam. Yes. Question. Final 2016, question 2, part A. Provide the correct conditions for the following code. So I have a program or a definition called decide admission and return student offer message. So students graded 5 more than the cutoff receive scholarships. There was a much longer explanation than this on the final. I just wanted to fit it onto the slide, but now I realize that maybe my explanation is subpar. I want you to write a function which takes an average and a cutoff and returns one of 3 messages. To accept the student with a scholarship, or to reject the student. And the rule is, well, obviously, if you're greater than or equal to the cutoff, you're accepted. And if in addition to being greater than or equal than the cutoff, you are 5 more than the cutoff, you get a scholarship. So cutoff plus 5 gets you a scholarship. So let's try coding this. And this is going to be a little bit difficult because the if else was set up for us, right? So we're going to have to be careful about how the conditions work here. So I'm just going to go into here, quit. What day is it today? Wednesday? Yes? Whoops. Do not save. Blah. What is this? I don't care. Okay, so we want to define, what was it called? Decide admission. We're going to be given an average and a cutoff. We're going to want to take a float and return a string. I'm not going to write in the doc string. But I will write some example code in here. So decide admission for someone who's right on the cutoff. That should be accept. Decide admission for someone below the cutoff. That should be reject. And decide admission for someone who is 5% over the cutoff is accept with scholarship. Now I'm going to write in the if statement here first because we have some restrictions. So it's if, and then I'll write some condition in a bit. Return accept. Else if some condition, return accept with scholarship. And then else return reject. Okay, so what should I fill in here? Well, the first one's easy. If the average is greater than or equal than the cutoff, then I should accept. Okay, now what? Huh? Exactly. So I'll repeat that so everyone can hear. This is already wrong. I'm happy you caught that, right? Because this is exactly how we were trying to trick you on the exam. If I got a scholarship, what would happen? right? If I went in here, and so anyone who's supposed to get a scholarship is going to have an average greater than the cutoff, right? By definition. So here I'm going to have to add what? You in the gray? I guess, sure. Yeah. We can't, right? You're working within the conditions of the final, right? So yes, there's always a different way to solve the problem, but they asked us to solve it in a very specific way. Yeah. Over there. Yes. Think that should do it? Think that should do it? I think that should do it. Eventually it will be correct. This looks okay. Yeah? Okay. Does everyone understand why we had to add that? Because if the first thing had triggered, we would have left the program, right? And anyone who was supposed to get a scholarship would merely have been accepted. Okay, so now what can I say here? So if average minus cutoff, if average minus cutoff is greater than or equal to 5, right, then we do this. Although, what happens if I guess we can assume that the average can't be negative. Right, so I can write something in here called assumptions. You may have seen this. Average right, so if you want to sort of give more information about what you're expecting, we can do that. And then else reject. Okay, so let's just give this a try. I'm going to read this code into my interpreter. What was it called? Decide admission. Decide admission for someone. I'm just going to run my doc examples. 8080. Accept. Decide admission for 7475. Reject. Decide admission for 9590. Accept with scholarship. Perfect. Okay. So we made another mistake. No, I don't. Okay. Maybe this was pointless. Yeah, I made a mistake, right? Because if average minus cutoff is greater than or equal to 5, then average has to be greater than or equal to cutoff. Yeah? Well, it depends on the context of the question. If the context of the question was remove redundancies from this code, and you left redundancies in, then yeah. No, we're not here to grade you down. I'm your buddy. I want you to pass, and I want you to pass with the most amount of grades that you can. So as long as your code basically works and isn't, again, it's contextual. If you put a really bad redundancy, then I'm going to grade you down. If you do something like this, if you make a mistake that your professor is capable of making, then of course not, right? So this is fine. But generally, those who are more concerned about learning computer science will do better than anyone who's sort of trying to hunt down these grades. But this is incorrect, right? And it's a good lesson, right? Because if this is the case, then this has to be the case, right? So this is about removing redundant logical conditions, right? Okay, so ignore that. I'll remove that for the slides later. The follow-up to this is I want to refactor it. Yes, question. Yeah. Okay, so let me write that. Okay, so we want to write, so it is the case that Python, so we can do this. If A is less than B and B is less than C, that I can also write this. A is less than B is less than C. So let me go into the interpreter. So if I have A, B, C, and this is 1, 2, 3, A is less than B is true, B is less than C is true, and thereby A is less than B is less than C. I don't actually, can we do more? Yeah, okay. Oh, false. True, yeah. So you can actually combine these less than or equal to's into statements like this, where basically you have to bracket every pairing and make an and, right? So if this if I had this, this is equivalent to A less than B and B less than C and C less than D. Okay? I didn't teach you this because it's not really, it's just sort of a short form writing of something. Right? So I didn't want to confuse you basically but you can do that with threes. Anyways, let's try and refactor this code somehow. So let's now pretend that we're not within the constraints of the exam. How can we write this better?
We can make the case of scholarship be the if statement, and the case of making it without making scholarship as the else statement.
Okay, so that's one good way of doing this. So we can simply swap these conditions. And then swap the returns. Right? I'm with you. How did now I have that and I don't want it. How do I hide you? Yes, okay. What is going on? And then I can remove this. Okay, so there's one simplification, right? So that we're going to check if the student gets a scholarship first. And then if the student gets a scholarship, then we can stop. And then if he doesn't get a scholarship, we can say, okay, maybe do you get accepted? And if the student's not accepted, then we can reject. Right? So that's one good way of rewriting this. Another way is to do this. So this is the way that I did it in the slides. First, I'm going to see if the student even gets into the university first. And then I'm going to check if the student gets a scholarship. And if he gets a scholarship, then I can return accept with scholarship. Else, just get a regular acceptance. And then if everything else fails, return reject. Yes? Yes, I can also remove this. That's another way of doing it, right? Just by exploiting the nature of returns escaping the function, right? So if the student passes this if statement, then for sure student is at least accepted, right? And if we reach this part of the code, student for sure wasn't accepted, right? Yes? If this, yeah, it is almost as if it's an else statement, yeah. Except that there's only, so if it basically, like, if statements aren't overly complicated if you just remember that they're just skipping code, right? So if this fails, then this basically to Python doesn't exist. And if this doesn't exist, it's going to return that except. Right? So there's two ways of doing the same thing. Oh boy. Okay, here's 10 minutes. So I'm going to skip this one. You do it. Evaluate F2, F13. There's the answers. You do this one as well, because I really want to get to this one. This is an interesting one. So I'm going to open some code, and we're going to refactor it. So and that code is somewhere here. Oh, yeah. Okay. There's some code. It's super complicated. All right, let's see if I can. Okay, that's all of it. It's all of it on this. No, it's not. That's all of it. Okay, so let's try in the next 10 minutes to try and simplify this code and see what we get. Okay. So if x is greater than 100 and y is greater than 0, so if this triggers, then it is for sure the case that x is greater than 100 and y is greater than 0. So if y is greater than 0 here, then for sure this is redundant, right? This is just true. Oh, geez, I did it in reverse. Sorry. If x is greater than 100, then for sure x is greater than 0. Okay, so this can go to true. If y is greater than... What else do I got here? And true. Okay, so I can remove the and true, because that doesn't matter. So what do I have now? If y is greater than 100, then return a. If y is greater than 100 or x is greater than y, return a. So this is a redundant condition. Right? Yeah. Pardon me? Yes. Yeah. All of you are getting ahead of me. I'm trying to be really careful here. Okay, so we know that x is greater than 100, so x is greater than 0 is true. Yeah? Okay, so I guess then this whole thing is true. Right? Right, because of the or. You want to start over again, and I'll go slowly, okay? Let's start all over again. Fresh start. Okay. We're going to enter the code, right? And we're going to suppose that this if statement toggled, and that my Python interpreter is at line 3. So at line 3, it is, we know x is greater than 100 and y is greater than 0. Okay? So given that x is greater than 100, we know that x is greater than 0, yeah? Right? Because if x is greater than 100, this means that x is greater than 0. Right? That's a pretty basic inference, right? So I'm going to change this to true, and I'm going to change this to true. Yeah? Okay. So it means this else statement is pointless, right? Because anything or true is true, right? So that means this else will never trigger, right? Because if y isn't greater than 100, then it's going to trigger this, right? So I'm just going to remove this. Yeah. No, I'm going to remove... Yeah, I know. I'm just calling out things. Like, again, I think we're all coming to the same destination in different orders, right? Because it can never trigger, right? Because if true just becomes else, right? If y is less than 100, then else true return a, right? This else will never trigger. Right? Okay. No, it won't, because this is an or, right? Or true, right? Are you with me? Yeah? Okay, so since it's or true, this is going to short circuit, well, won't short circuit, but anything or true is true. So the first condition is I don't care about the first condition. True or false, it's going to evaluate to true. Yeah? Okay, so I'm going to remove that. So if true actually just becomes else. Then this disappears. So we have a if condition where both branches return a, right? So actually, I don't care about this if condition. Right, we just return a. Okay, so that simplifies the first one. You may have to go home and redo this by yourself, right? Because I am also kind of rushing. Okay, so the first condition, return a. Okay, so now I'm in here. So what can I assume here? I can assume that is not the case that x is greater than 0 and y is greater than 0. Which is what? It means that it is not the case that x is greater than 100, or it is not the case that y is greater than 0. Which means that it is the case that x is less than or equal to 100, and y is less than or equal to 0, right? Those are equivalent statements. So I'm just going to take this. Okay, so we can assume that this is the case, and that this has passed, right? So y is less than or equal to 0, or x is less than or equal to 0. So let's see what we can try to do. If x is equal to y, return a. Okay, I can't really act on that. If x is less than or equal to y, and x is greater than or equal to y. Okay, so what is the only condition where this will occur? Well, this will trigger. How can x be less than or equal to y and x be greater than or equal to y?
When x is greater than y. No, I can't. It's,
When they're equal, right? So this condition is dumb. It's just the condition before, which would trigger before. Okay. Was that an else? Oh yeah, those were ifs, right? So this condition is just this, which means that if this was true, then A would return. So I can get rid of this. Okay, if y is less than x and x is less than y, return C. So what can we conclude about these things? If y is less than x and x is less than y. Oh yeah, this is impossible, right? This is a contradiction, right? So if false, return C. So actually this just returns A. Okay, so if x is equal to y, return A, else return A. Well, let's just return A, right? Okay. Last one, if x is less than or equal to y. Okay, so here I again can assume, right, what are we assuming? We're assume that x is less than or equal to 100 or y is less than or equal to 0. And it is the case that y is greater than 0 and x is greater than 0. So we actually have a bunch of conditions. So if x is less than or equal to 100 and y is greater than 0, well, we do have both of those assumptions, right? So this triggers, right? So these conditions are pointless. So what does this simplify to? And that's why we refactor code. I'll see you guys on Friday. Go home. There's 2 questions I didn't do. I want you to go do them. And then try to refactor this on your own time. Yeah.
Just for us to download PyCharm and then code on there, because like it shows you like the spaces, it shows you like.
Oh sure, but like so like mine is doing that as well, showing the spaces. Like,
yeah, but I don't have a Mac, so like I have a PC.
oh, you can get VS Code for Mac too, but like it doesn't matter. Any program which will show those empty spaces and do syntax highlighting is fine.
Because I just do it in like the IDLE.
IDE, yeah, interactive development environment.
Yeah, I just do it in that.
That's fine. Yeah, that's perfectly fine.
Because it like, but I've found in the past that it doesn't help me with like alignment of like. I want it like when you're doing your if statements, if you don't know if this is on the same line as this one.
Okay, then that's a problem.
Yeah.
Right?
So
then you should switch to a text editor with monospaced
so
editing.
you suggest VS?
VS